Which of the following cases will generate an EMF in a conducting loop? A magnet sits outside a loop. All right, so we have a magnet, we have a loop. If they're just sitting there and there's no motion happening, then that's not going to generate an EMF. The magnet moves towards the surface of the loop. So magnets moving towards the loop, that will generate an EMF. Here, this one's a little trickier. A loop moves to the right with a speed of 0.5 meters per second, and a magnet in front of it also moves at a speed of 0.5 meters per second to the right. So they're both moving, but they're both moving in the same direction at the same speed. So the distance between them is not changing. This will not cause an EMF. We need there to be relative motion between them. This, even though they're both moving, this does not generate an EMF. D, a loop that has steady current flowing through it, so let's say we have a loop of wire over here with current flowing, is next to our conducting loop. As we went over before, if it's steady current, creating a steady magnetic field, that will not create an EMF in the second loop. It's only right when the switch here is closed and opened, when the magnetic field is changing, that we get an EMF in this loop, not when there's steady current going, creating a steady, unchanging magnetic field. So the answer is B.